Hey guys, in this problem, I'm talking about a balloon being inflated at a rate of 10 pi cubic feet per second. So since I see the word inflated, I know we're talking about the balloon's volume. And since it says rate, I know we're talking about the derivative of the balloon's volume. So I'll label this as dV dt equals 10 pi cubic feet per second. At what rate is the radius increasing? So since I see the word rate and radius, I know we're talking about the derivative of the radius. So I'll label that dr dt. And we're trying to find that, so I'll put a little question mark there. When r equals 2 feet, so that's already labeled up for me, r equals 2. Cool, so I have the problem all labeled up, and now I'm going to have to pick a formula that describes this situation. Since we're talking about a balloon being inflated, we're talking about the volume of the balloon. And in this problem, we're going to think of a balloon as a sphere. So volume equals 4/3 pi r cubed. So after we come up with the formula, we're going to do the calculus because this sphere is growing. So we're going to have to do the derivative of our volume. So the derivative of v would be dV dt. And this 4/3 is a constant multiplier, so we'll just leave that hanging out, 4/3 pi. And the derivative of r cubed will be 3r squared dr dt. Cool, so I have my derivative. I'm just going to clean it up a little bit. And we'll say that dV dt is equal to 4 pi r squared dr dt. Cool. So now I can go to the algebra part and I can substitute. dV dt was given to us. We know that that's 10 pi. And we know that we're trying to find this rate of our radius when the radius is equal to 2, so we can substitute now 2 for the radius, and we don't know dr dt. So 10 pi equals 4 pi times 4, so 16 pi dr dt. And a little division, 10 pi over 16 pi equals dr dt. And I see that the derivative of my radius is going to be 10 pi over 16 pi, or 5/8. And let's talk about units. The units for my radius was feet. The units for my time was seconds. So dr dt will be measured in feet per second. Now, in the context of this problem, the balloon is being inflated at a rate of 10 pi cubic feet per second. That means the radius is increasing. So the radius of our balloon, here's our balloon. So this radius is growing at a rate of 5/8 feet per second.